Okay, by now we have gotten to the place where we are solving quadratic kind of problems, like tangent squared of theta plus 3 tangent of theta plus 2. We just solve that one quick, just for review, to make sure you're on top of what you're supposed to be easy so far. This should be easy by now, or at least doable. And we've said we want the answers between 0 and 2 pi, meaning there's oftentimes 2 answers for each side of the factor. And sometimes there's 2 answers on the left side and 2 answers on the right side, making a total of 4 answers. Now this isn't an insanely hard problem, but it is definitely a goes away. It is definitely a hard problem, and I want you to just think about how you should be proud of yourself. You are at a high level in math. Many kids nationwide will not get to Precalc. Many kids nationwide will end at higher algebra, the class before this. That will be the highest math they'll ever get to. And then in college, they will struggle through college algebra as the only requirement for a lot of majors, and they won't have to do this either. So you're at the stuff now where you're above a lot of kids. Is there stuff above this? Yeah, sure, of course there is. There's always something above. There's always something higher. But you're at the point now where you're doing math that a lot of people will never, ever get to. Okay? And just up until now, you couldn't really say that. Most kids throughout the nation get through Algebra 2. But most kids in the nation won't get to this. So, yeah, it's hard. But that's kind of cool, too. You should be proud of yourself. All right. So, when you have something that's squared and something that's not squared and then a number, a lot of times you can end up factoring them. In fact, you don't even often need the number. Like this last thing is kind of optional. You don't have to have 2. But this one will work out nicest if I change it to this. Do you see what I just did? I made the problem so much simpler by taking out the word tan. Okay? Because now it's just factoring, and I can just go, I know how to factor. That's x and plus 1 and plus 2. And then I got to get the answer. X equals -1 and x equals -2. Now, tangent has to come back in. And now I've got a problem again. Now they're hard problems again. From here, I should be picturing where on the circle would this be. And if tangent is 1 over 1, that's a tangent, let me see, tangent opposite over adjacent. I can draw a triangle for that. Okay? And where is tangent negative? Oh, students take calc. Tangent is not negative here, so I hope you didn't draw your triangle there. Okay, tangent is not negative. Or, no, I just didn't say it that way. Tangent is positive down here also, so I can't draw it down there. But I should have 2 answers for this. One over here, where tangent's opposite over adjacent. The opposite's going to be 1 and adjacent's going to be -1. I know I switched to the negative, but that's okay. Negative can be down here. It's okay. And then this is square root of 2. So that's the 45 degree, and a lot of people get 45 and they'll be wrong, because that's not 45. The angle we really want is this one that wraps around 2 there. So it's not pi over 4, it's 3 pi over 4s. All right, so 3 pi over 4 is that answer. Is there another place I could draw the triangle? Yes. Did you catch? I pretty much stick to radians. I don't think there's been a single problem where degrees was requested. So if it doesn't label it, if it doesn't say, then you'd have your choice. But usually in the directions they'll say between 0 and 2 pi, and that implies 1. Okay, and the other time they asked it, they said, give the exact answer. Again, that implies radian. Okay, so now if I go down to the other place I can draw this triangle, and it also has a 45 degree angle right there, then really that's also known as pi over 4. So this is not 8 pi over 4, but 1 less than that, so 7 pi over 4. So there's my 2 answers for that side. Raise your hand if you get that. Okay, good. Now the other side. This one's not quite as easy. Tangent of x is equal to -2. Well, tangent's negative again, so it's going to be in the same spots. So I'm going to draw it Can't be here. Can't be here. How can I draw it so the opposite is 2 over the adjacent is 1? Actually, it'll have to be negative to make that work. 1, 2, and then this side must be the square root of 5. I don't know that, Tron. Well, and the only way we'd be able to do this one is to use a calculator. It can be done, but you'd have to use a calculator. Because you haven't memorized the 1, 2 square root of 5 triangle, have you? Unless you're really bored in your spare time. So I'm thinking you probably don't know that one. So you'd type in on your calculator. How would you get it on your calculator? I would change it to a what kind of a inverse? Inverse. So you go inverse tan of negative 2 over 1, which is just negative 2. And that will tell me what x is. All right, and once I know what that is, I've got one of my 2 angles. Then I have to figure out, using math, what the other of my angles was over here. But I don't think you're going to have that kind on the test because I don't think we're going to allow calculators on the test. And therefore, I'm not going to worry too much about that. All right, so if we just set this part aside over here, because again, for the scope of what we're doing, we don't need to handle ones with calculators. These two you should have been capable of doing those two. Now let's review where those actually are, because this is the new thing for today. The answers were there and over here. 2 different things. Now, do you remember how, if I get to here, I could also, if I wanted to, go all the way around and come back and get to that same spot. And the only thing that prevents me from having to give that answer is they say that the answer is supposed to be between 0 and 2 pi. What they changed for today, and you'll see on the test, some are going to ask for the answers to be between 0 and 2 pi, and some are going to say all the answers. Exactly, you could go on forever. So what do? You say the 2 answers that you had, but you say, okay, here's the 2 answers again, 3 pi over 4 and 7 pi over 4. But do you get that those could keep repeating over and over again? So what do? Listen, you know the answer to what you do? What do? You say plus or minus, what do you think? 2 pi. And that would only be once. And couldn't you go on and multiply it by 2 pi more, like 2 pi and then 4 pi and 6 pi and 8 pi? So then they say 2 pi n, or x. Yes, that should be fine. So plus or minus 2 pi n. That's how you say all the answers. So you just find the normal answers, but then you add on that plus 2 pi n, or plus or minus, I should say. Plus or minus 2 pi n here. Now, that assumes that n is an integer, because of course if you multiply it by 2 pi and then times that by 0.6, it won't work. It has to be a whole number like here. An integer. It's just an official way to say that. Yes? Nope. You should say the answer. If they ask for all the answers, you should say this, and you should say that. Okay? And you don't have to go on to tell me what n is. I get that n has to be a whole number. You don't have to describe it. All right. So the difference. There's really not much difference. It's just you throw on a plus or minus 2 pi n. That's it. It's the only new thing for today. And that's only if they ask you for all the answers, as opposed to the answers between 0 and 2 pi. All right? Okay. So, in this plus or minus thing, the only thing I'm worried about is if they say all the positive ones, well then don't say minus 2 pi. You know, if they ask for all the positive answers, you'd just say plus. But if they ask for all the answers, throw in a plus or a minus. In my opinion, that would be the best answer. Okay, so let's actually do some of your ones off the worksheet. Here we go. It's worksheet number 5. I happen to have some right here. It's more doable than the last one. The last one, you may recall, I cut down for you and told you didn't have to do the back side of it because it was obscenely large. I'm going to leave those as problems that you could do if you need to practice before the test. And oftentimes I get that question, if I wanted to do some more problems to practice before the test, what should I do? Well, now you got some. Oh, perfect. Perfect number of papers. All right, let's start. And I think once we get started, it always feels better. When the worksheet's blank and you haven't begun yet, it's always kind of depressing. All right, so Mr. JW in the second row, tell me number 1A. Okay, and what did the directions say? What am I supposed to do? Okay, so it's saying between 0 and 2 pi. This is not one of those kind that you have to do all the answers, just the ones between 0 and 2 pi. But a lot of times that means there's a couple answers. So, this does not look like a quadratic to me. Anybody got any ideas on how to start this puppy? All right, let's get the cosine out of there. How are we going to get the sine out of there? Maybe we should just get the sine out and then there'll only be cosines left. All right, I think I'm going to go with get rid of the sine. So if I'm getting rid of the sine, what should I put? Oh, wait a minute. You know what? There might be something else I can do first. There might be something even better. We'll still have to get rid of that sine later, but... See how those cosines, they're both like, there's two cosines? Factor it. Get the cosine out. Okay. 2 sine x minus 1 equals 0. Okay, now, here's the cool part that a lot of people wouldn't have thought of. Do you get that whenever it equals 0, that once you got it down to something being multiplied, then either this has to be 0 or that has to be 0? I don't have to do anything complicated here. I can either cosine x can be 0, or all of that can be 0. So I set up two little equations. Cosine x has to equal 0, or 2 sine x minus 1 has to equal 0. It's just like this kind where we factored it down to x plus 1 and x minus 2 equals 0. Either this is 0 or that's 0. Okay? Same, just like that. All right, so where is cosine of an angle equal to 0? Remember, the 0 is like the sides. That's not a normal triangle, right? So it's one of the quadrantals. And remember, the cosine is the whole x over r thing. So x is 0. And so where is x 0? It's either here or here. Let's see if that spot right there would be 1 comma 0. This would be, no, it wouldn't. That would be 0 comma 1. Sorry. 0 comma 1. And this spot here would be 0 comma negative 1. And x is 0 at both of them. 0 divided by 1 or 0 divided by negative 1. Either way, no, wait, the radius is 1. Sorry. Forget that. The fact that this is 1 is irrelevant. This is 1 and this is negative 1. All that matters is x is 0. So yeah, like you said, somebody said, both of them. All right, so if both of them are the answer, then what are the answers? Pi over 2 and 3 pi over 2. Good. All right. And then over to the other side. This one's just a little more complicated because first I got to solve it a little bit. So I add 1 to both sides, and I get 2 sine x equals 1. So sine x has to equal a half. Ooh, I know that one. What is it? 30 degrees, but there's another answer too. Remember? Remember, if this is 30, then where's the other answer for this thing? Well, where are the two spots where sine is positive? All students take calc. There's two spots where it's positive, not there, not there. So it has to be over here. So it's 30 and 150, but we usually say it in radians. So that's pi over 6 and 5 pi over 6. Good. There we go. I know. I agree. When we do this next year on iPads, we will have like 1 page per problem, 1 problem per page, because you'll be able to you have a whole sheet. Because kind of the cool part is all of a sudden you can think outside the worksheet. Because worksheets, we try to cram it all on 1 page to save paper, but when it's not digital, it doesn't matter. So we can have like separate pages for each problem. Okay, I'm having 3 people talking at once. What? Yes, on the regular worksheet, we could make it a little bit better, but the reality is, if I were you, I'd probably take a piece of paper, like a lined paper, and set it next to my worksheet and do it over there. It's your choice. If you want to do it on the worksheet and you write really small and you can understand it, cool. if you want to just take a separate sheet of paper out and do it over there. I know. Look at how much room I use up. That's like a whole, relatively speaking, like a half a piece of paper. I get that. It's not enough room, so I agree. All right, let's move on. Are there any other types of problems? Yes, look down at problem 2. What directions say there? Find all the solutions, which means you find all the solutions like you would before, which would be there's 2 different quadrants usually where there's an answer, so that'll mean 2 solutions. But then you say plus 2 pi n, plus or minus 2 pi n. Okay, so there you go. Got a bunch of time to work because there's not too much new today. And then the good news, especially good news, is Monday is going to be another day like this where we have a chance to work a lot. And don't waste this time. You've got a teacher right here willing to explain it to you. If you're stuck, get help. Don't just sit there. You really want to do your English assignment right now? I guess I can live with that as long as you're working hard during the time. All right. Okay, hold up. I'm actually going to show you one more. If I were you, I would look at problem number 3 right now. And it's supposed to be where it's problem 3 starts, but it actually says problem 2 again. So basically, it's the last section on the worksheet. Come with me to the last page, guys. Turn to the last page. You're looking at A of the last section. It says 2A, but it's really supposed to be 3A. All right, and would you read me that one, Miss B in the front row? Square root of 1 minus x squared. X equals cosine of theta. Okay. It says make the substitution. Yes? Okay, just let me do the problem here. Okay? So I'm not just going to answer what the answer is. So this goes in here. We're supposed to substitute this in here. That's what they mean by the substitution. So we go square root of 1 minus empty spot squared. I'm going to drop in cosine. So it ends up being cosine squared. So stop. Okay. I don't. Okay, that's the part. That's part of it. Okay. All right, back to what do? We replace 1 minus cosine squared. That part right there, that can be sine squared, because that's one of the identities. Is that sine squared is equal to 1 minus cosine squared. It comes from this one. Sine squared plus cosine squared equals 1. It comes from that. That tells us that this part right here can be sine squared. And then we got the square root of sine squared. Square root of sine squared is sine. So yes, the answer is sine. All right, so that's how you do that kind on the back side, last part of the worksheet.